What if the oldest story ever told was not a myth but a map left behind by the very first civilization, charting a path so extraordinary, so impossibly advanced that for 6 millennia it has been mistaken for simple legend, a map that points not to a terrestrial treasure but to a visitor from another star. For thousands of years we have lived under the comforting illusion that our solar system is an island universe, a self-contained cosmic terrarium isolated from the vast, turbulent ocean of the Milky Way. We believed the 8 planets, their moons, and the swarms of asteroids and comets were our celestial family, a familiar, predictable dance governed by the gravitational heartbeat of our sun. The space between stars was thought to be a sterile, unbridgeable chasm, a void so profound that nothing could ever cross it. We thought, entirely alone in our cosmic neighborhood. That comfortable certainty, an idea that had anchored humanity for its entire existence, was shattered on the 19th of October 2017. It began not with a bang but with a whisper. A single anomalous pinprick of light, captured by the unblinking eye of the Pan-STARRS telescope, perched atop the Haleakala volcano in Hawaii. To the sophisticated algorithms that sift through the nightly deluge of data, it was just another faint object moving against the fixed backdrop of stars. The initial designation was mundane, A 2017 U-1, the A for asteroid. The system doing its job flagged it for a routine follow-up. But as astronomers around the world began to track its trajectory, a collective sense of bewilderment rippled through the community. This was no ordinary rock. The object was moving at a blistering 196,000 miles per hour, a speed so extreme, so utterly untethered to the sun's gravitational influence that it defied all classification. Our sun's gravity is a cosmic well. Everything that belongs to our solar system is trapped within it, forever falling around in circular or elliptical paths. To escape that well, an object needs to achieve escape velocity to be fired from a gravitational cannon of immense power. This visitor was not slowing down as it departed. It was moving so fast that it was clear it had never been a captive at all. It was a tourist, a traveler just passing through. The calculations were checked, rechecked, and confirmed by observatories across the globe. The verdict was inescapable. The object's orbit was not an ellipse, the closed loop of a planet or asteroid. It was a steep, dramatic hyperbola, the unmistakable signature of a path that originated far beyond our star. This was a celestial fugitive, a ghost from interstellar space, the very first one we had ever seen. It was given a new name, one befitting its groundbreaking status, a Hawaiian name that means a messenger from afar arriving first. It was called Oumuamua. The discovery was monumental, a moment that fundamentally altered our place in the universe. We were no longer on an island. We were standing on the shore of a vast interconnected cosmic ocean, and the first piece of alien driftwood had just washed ashore. But as the initial wave of exhilaration settled, it was replaced by a deeper, more unsettling emotion, profound confusion. Because the more we looked at this messenger, the less sense it made. Its first mystery was its light. As Oumuamua tumbled through space, its brightness varied by a factor of 10, a change more dramatic than any asteroid or comet ever observed in our solar system. This wild fluctuation in luminosity told us something astonishing about its shape. It wasn't a roughly spherical potato like most asteroids. To explain the light curve, it had to be impossibly long and thin, at least 10 times longer than it was wide. The model suggested a shape like a cosmic cigar, or perhaps a completely flat pancake-like shard tumbling end over end on its journey out of the solar system. Such an extreme elongation is a nightmare for planetary scientists to explain. Natural objects ground down by eons of cosmic collisions and sculpted by gravity simply don't look like this. It was an architectural anomaly, a form without precedent, a splinter from a celestial tree we had never seen. Yet the enigma was only just beginning to unfold. If it wasn't an asteroid, perhaps it was a comet flung from its own distant star system by some gravitational disturbance. Comets, after all, are the solar system's great travelers. But comets have a telltale signature. As they approach a star, the heat vaporizes their icy surfaces, creating a beautiful glowing atmosphere called a coma, and often a spectacular tail of gas and dust that can stretch for millions of miles. The Hubble Space Telescope, our most powerful eye in the sky, was pointed directly at Oumuamua. It stared with unparalleled precision, searching for the faintest hint of outgassing the slightest wisp of a cometary tail that would solve the puzzle. It found nothing. Absolutely nothing. Not a single molecule of water, not a flicker of carbon gas, not a grain of dust. Oumuamua was bone dry, inert, and completely silent. It was a comet with no coma, a celestial iceberg with no melt. This is where the mystery deepens into a scientific paradox, a contradiction that has fueled years of intense and sometimes ferocious debate. As Oumuamua began to pull away from the Sun, making its final exit from our cosmic stage, astronomers tracking its path noticed something else that was deeply wrong. It was deviating from its course. The object was accelerating, pushed by a faint, mysterious force that could not be explained by the Sun's gravity alone. It was as if a gentle, invisible hand was giving it a slight nudge, speeding it up on its way back into the interstellar darkness. For a comet, this phenomenon is well understood. The outgassing of jets of gas and dust acts like a series of tiny rocket thrusters, pushing the comet's nucleus and altering its trajectory. But Oumuamua had no jets. It had no outgassing. It was a sailboat moving through the vacuum of space with no wind in its sails. This non-gravitational acceleration, combined with its bizarre shape and its dry-as-a-bone composition, pushed Oumuamua out of the realm of the familiar and into the territory of the truly profound. What was this thing? What force could be pushing it? Some scientists, struggling to find a naturalistic explanation, proposed exotic theories: a solid hydrogen iceberg evaporating in a way we couldn't detect, or a celestial object of a type so alien we had no category for it. One prominent and controversial hypothesis, put forth by Harvard astrophysicist Avi Loeb, suggested the unthinkable. The gentle push was from the pressure of sunlight itself. For that to work, Oumuamua would have to be incredibly thin and lightweight, a solar sail, a piece of technology, a relic. The implications were staggering, sending a shockwave not just through astronomy but through all of human thought. But what if the answer was not to be found by looking forward into the speculative future of alien technology, but by looking back into the deepest, most foundational moments of our own past? 6,000 years ago, long before the pyramids of Giza pierced the Egyptian sky, before the stones of Stonehenge were raised, a civilization bloomed in the fertile crescent between the Tigris and Euphrates rivers. We call this land Mesopotamia, the cradle of civilization. And we call its people the Sumerians. It was here in what is now modern-day Iraq that humanity took a giant leap. The Sumerians invented the wheel, they developed agriculture on an industrial scale, they codified the first laws, and they gave us the 60-second minute and the 60-minute hour we still use today. But their most transformative invention was a way to capture thought itself. They invented writing. On soft clay tablets, using a reed stylus, they pressed wedge-shaped marks known as cuneiform. And on these tablets, they recorded everything: their commerce, their histories, their poetry, their myths. And most importantly, they recorded the heavens. The Sumerians were master astronomers. They meticulously tracked the movements of the sun, the moon, and the 5 visible planets, which they believed were the physical manifestations of their gods. Their temples were also observatories, their priests were also sky watchers. For them, the celestial realm was not a distant abstract space, but an active divine landscape that directly influenced life on Earth. They created the first star charts, a zodiac, and were able to predict eclipses with remarkable accuracy. For centuries we have studied these tablets, seeing in them the birth of science, a primitive but brilliant first attempt to make sense of the cosmos. We've marveled at their precision, but always within the context of their time, assuming the absolute limits of what was possible with the naked eye. But hidden within this vast library of baked clay, a library containing hundreds of thousands of tablets, lies a claim so audacious, so earth-shattering, that it has been relegated to the fringes of academic thought, a theory that suggests the Sumerians knew more than we could possibly imagine. The claim is this: that on one specific, unassuming tablet amidst the litanies to gods and the records of grain harvests is a star map of a very different kind. It is not a chart of any known constellation. It does not depict the familiar looping path of a planet. Proponents of this theory argue that when this ancient diagram is analysed, not with the naked eye, but with the power of modern computers, it traces a unique and startling trajectory. It shows an object entering our solar system from a sharp, impossible angle, swinging around the sun in a tight curve, and then exiting never to return. The chart, they claim, describes a path that is not a closed ellipse, but an open hyperbola, an interstellar orbit. For an ancient civilization to have recorded such a thing should be utterly impossible. It would require knowledge they could not have possessed, an understanding of the sun as the center of the solar system, a mastery of complex orbital mechanics, and the ability to somehow observe an object that by its very nature would appear only once in the sky for a brief period before vanishing forever. And here is where the story of Oumuamua, the messenger from the future of astrophysics, collides head-on with a potential message from our most distant past. Because the proponents of this theory claim the orbit depicted on the Sumerian tablet is not just times any times interstellar orbit. When they overlay the 6000-year-old cuneiform map onto the 21st century trajectory of Oumuamua, they claim it is a perfect match, a one-to-one correspondence, a celestial prophecy written in clay fulfilled 6 millennia later. Is this possible? Could a civilization that had just invented writing somehow possess a piece of astronomical data so advanced it would not be rediscovered for thousands of years? Is it merely the greatest coincidence in human history, a case of pattern-seeking wishful thinking, where modern researchers project their own discoveries onto the vague scribbles of the past? Or are we staring at a piece of evidence that could rewrite not just the history of science, but the history of humanity itself? Evidence of a lost knowledge, a forgotten chapter in our own story, or perhaps the legacy of a different kind of messenger, one that visited our planet long ago? This is not a simple question. It is a labyrinth, a dizzying journey that will take us from the clean rooms of NASA's Jet Propulsion Laboratory to the dusty archives of the world's greatest museums. We will stand at the forefront of astrophysics with the scientists who are still struggling to understand the enigma that is Oumuamua. We will delve into the world of archaeology and cuneiform studies, speaking with the Sumerologists who have dedicated their lives to deciphering these ancient texts. We will confront the impassioned believers who see undeniable proof of ancient wisdom, and we will face the hard-nosed skeptics who demand rigorous, repeatable evidence. We must navigate the treacherous line between groundbreaking discovery and unsubstantiated fantasy, between scientific revolution and modern myth-making. The stakes are nothing less than our own origin story and our future place among the stars. The journey to find the truth behind 3i, Atlas, begins now by first understanding the true bewildering nature of the messenger that started it all. What if the universe sends a message in a bottle and we are only just now learning how to read the script? Not a signal of modulated radio waves, not a complex mathematical broadcast, but something far more primal, a physical object, a silent, solitary traveller hurled from the darkness between the stars, carrying with it the secrets of its origin. For millennia we have stared into the cosmic ocean, wondering if we were alone. We never expected the answer to wash up on our shore unannounced, a fleeting shadow against the light of our own sun. It began as the faintest whisper in a symphony of data, a single anomalous pixel on a digital sensor. On the summit of Haleakala, on the Hawaiian island of Maui, a sentinel stands guard. Not a warrior of flesh and blood, but a silent, unblinking eye of silicon and glass. This is the Panoramic Survey Telescope and Rapid Response System, or PAN-STARRS. Its nightly mission is a monumental act of cosmic vigilance to map the heavens, to catalogue the ever-shifting population of asteroids and comets that haunt our solar system. Every night, it drinks in a torrent of information so vast it would overwhelm 1,000 human minds, sifting through the familiar celestial landmarks for anything new, anything that moves against the stellar backdrop. Its software, a masterpiece of pattern recognition, is trained to spot the subtle signature of a threat, a near-Earth object on a collision course. But on the 19th of October 2017, the system flagged something that wasn't a threat, it was an impossibility. The initial designation was unremarkable. A 2017 U1, a simple code for a newfound object. Yet, as astronomers around the world were alerted and began to train their own instruments on this fleeting visitor, a profound sense of unease began to ripple through the community. The first calculations of its trajectory were baffling. They didn't trace the graceful closed ellipse of a planet, an asteroid, or a returning comet bound forever to the gravitational anchor of our Sun. Instead, this object's path was a dramatic, open-ended curve, a hyperbola. That single geometric term changed everything. It was a mathematical confirmation of a cosmic trespass. This wanderer was not from here. It had fallen into our solar system from above, from the Sun's north pole, moving at a blistering speed of over 57,000 miles per hour relative to our star. It was moving so fast that the Sun's immense gravity was little more than a temporary inconvenience, a gravitational slingshot that would bend its path but could never hope to capture it. It was already on its way out, a ghost in the machine destined to return to the interstellar abyss from which it came. We had never seen anything like it. For the very first time in human history, we had incontrovertible proof of a visitor from another star system. The astronomical world ignited. A frantic, desperate race against time began. This was not a stationary target to be studied at leisure. It was a fleeting opportunity, a brief window into the great unknown that was closing by the second. Telescope time, the most precious commodity in astronomy, was reallocated with unprecedented speed. Giant observatories across the globe from Chile to Spain swiveled their immense structures to catch a glimpse of the phantom before it vanished into the glare of the sun and then back into the void forever. We gave it a name befitting its origin, a Hawaiian name that resonated with its profound mystery. Oumuamua. It means a messenger from afar arriving first. But what kind of messenger was it? As the data trickled in, the mystery only deepened, twisting from a scientific puzzle into something that felt almost unsettlingly alien. We couldn't get a clear image. It was far too small and too distant. All we could measure was its light, and the light was bizarre. It was fluctuating in brightness wildly, by a factor of 10 every 7.5 hours. This was not the gentle pulse of a typical tumbling space rock. Such an extreme variation suggested a shape unlike any asteroid or comet we had ever charted. To explain the light curve, astronomers had to posit an object of radical dimensions. It was either an impossibly thin flat disk, a cosmic pancake tumbling end over end, or more likely a tremendously elongated shape. A celestial cigar, perhaps 10 times longer than it was wide, spinning through the void. It was an architecture of nature or of something else that defied our local experience. Its colour offered another clue, another piece of the enigma. It was dark reddish, the characteristic hue of an object that has been weathered not by wind and rain, but by eons of exposure to high-energy cosmic rays in the frozen vacuum of interstellar space. This was no freshly broken piece of rock. This was an ancient mariner, its hull stained and hardened by a journey of unimaginable length, perhaps hundreds of millions or even billions of years. It carried the dust of other suns, the memory of a birthplace we could only guess at. Was it a fragment of a shattered planet? The core of a long-dead comet? Its icy shell blasted away over countless millennia? Or was it something else entirely? The theories flew thick and fast, each more exotic than the last. But the final confounding observation was the one that tipped the scales from mystery to genuine scientific crisis. As Oumuamua swung past the sun and began its long journey back out into the galaxy, astronomers tracking its escape noticed something was wrong. It wasn't following the path that gravity alone dictated. It was accelerating. Some other force, a tiny but persistent push, was acting upon it, nudging it ever so slightly away from the sun. The most obvious explanation for this kind of non-gravitational acceleration is outgassing. Comets, as they warm near a star vent, jets of gas and dust from their icy surfaces acting like miniature rocket thrusters. But if Oumuamua was outgassing, where was the evidence? The world's most powerful telescopes stared, searching for the telltale fuzzy coma, the beautiful ethereal tail that defines a comet. They found nothing, not a wisp of dust, not a trace of gas. The messenger was silent, propelled by an invisible engine. The object was a paradox, a collection of contradictions that strained the limits of our astrophysics. It had the trajectory of a comet, but the appearance of an asteroid. It was shaped like nothing we knew, and it moved in a way we could not explain. It was here and then it was gone, leaving behind a trail of profound and tantalizing questions. It forced us to confront the possibility that the cosmos is not only stranger than we imagine, but stranger than we can times imagine. And yet, to truly grasp the seismic shock of this discovery, to understand why the arrival of a single silent rock could so thoroughly unsettle our view of the universe, we must cast our gaze back before the age of digital sensors and space telescopes, back before the language of calculus could even describe the arc of its flight. We must journey back 6,000 years to a sun-baked land between two rivers where the first cities rose from the dust. Here in ancient Mesopotamia, in the fertile crescent of what is now Iraq, the story of human civilization and of our relationship with the stars truly begins. This was the land of Sumer. You are standing on a flat, alluvial plain under a vast and unforgiving sky. There are no mountains to block your view, no forests to obscure the horizon. There is only the earth below and the heavens above, and in this world the sky was not just a beautiful backdrop, it was a clock, a calendar, a map, and a holy book all at once. The Sumerians, a people of extraordinary ingenuity and discipline, were the first to understand that the sky was a place of order, not chaos. They were the inventors of writing, pressing wedge-shaped marks into wet clay with a reed stylus. This script cuneiform allowed them to record more than just inventories of grain or the deeds of kings. It allowed them to record the sky. On these humble clay tablets, they built the very foundations of astronomy. They were the ones who divided the day into 24 hours, the hour into 60 minutes, the minute into 60 seconds. Their base 6-0 mathematical system is the reason our circles still have 360 degrees. Their priests, who were also their first astronomers, climbed the towering ziggurats, stepped pyramids that reached toward the heavens to conduct their nightly vigils. They tracked the movements of the sun and the moon with meticulous precision, developing calendars so accurate they could predict lunar eclipses. They charted the strange wandering paths of the 5 visible planets, the wild sheep of the celestial flock, distinguishing them from the fixed stars. They grouped those fixed stars into the first constellations, giving us the zodiac, a celestial belt that became a framework for mapping both time and space. For the Sumerians, this was not a purely scientific exercise. It was a sacred duty. The movements of the celestial bodies were divine omens, messages from the gods that dictated the rhythms of life on Earth. The rising of a particular star cluster signaled the time to plant crops. The phases of the moon set the dates for religious festivals. The sky was a living, breathing entity, a reflection of a cosmic drama in which humanity played a small but significant part, and they wove their observations into a grand and terrifying creation epic, a story that reveals just how they perceived their place in the universe. This was the Enuma Elish. It tells of a time before time, when the cosmos was a swirling, watery chaos personified by the great mother goddess Tiamat. From this chaos the other gods were born, bringing with them light and order, which disturbed the primordial darkness of their mother. A brutal celestial war erupted. Tiamat, the dragon of chaos, created a legion of monsters to destroy her descendants. The fate of the universe hung in the balance. The younger gods, terrified, turned to a champion, the powerful, brilliant Marduk. He agreed to face Tiamat, but only if he were granted absolute authority over the cosmos. In a battle that shook the heavens, Marduk wielded the 4 winds as a net trapping Tiamat, before slaying her with a great arrow that split her in 2. It was a moment of cosmic creation through violent division. From one half of her body, Marduk formed the sky. From the other half, he fashioned the earth. To keep the upper waters from crashing down, he established a celestial barrier, a great band across the heavens. The text calls it the hammered bracelet. To modern astronomers, this sounds uncannily like a mythological description of the asteroid belt, that band of shattered rock that separates the inner terrestrial planets from the outer gas giants. Marduk then organized the universe. He established the constellations as stations for the great gods. He set the moon in the sky to mark the passage of the nights and the months. He created humanity from the blood of Tiamat's monstrous consort, shaping us from the clay of the earth to serve the gods, to build their cities and maintain their cosmic order. For centuries, scholars have studied the Enuma Elish and the vast library of Sumerian astronomical texts as magnificent examples of early religion and proto-science. We see in them the human mind's first great attempt to impose meaning on a vast and intimidating universe, to transform the terrifying chaos of the night sky into a predictable, divinely ordered system. We see the birth of mythology as a way to explain natural phenomena, a cosmic battle to describe the formation of the solar system, divine decrees to explain the regular motion of the planets. This has been the accepted view, the comfortable orthodox interpretation of these ancient records. But for some, this view is incomplete. In the last few decades, a number of independent researchers, linguists, and authors operating on the fringes of mainstream academia have proposed a far more radical interpretation. They look at the same cuneiform tablets, the same star charts, the same epic poems, and they see something else hiding in plain sight. They ask a provocative question. What if the Sumerians were not just inventing myths? What if they were recording history? A history so ancient and so strange that without the proper context we could only interpret it as allegory and fantasy. These revisionist scholars point to the astonishing specificity of Sumerian astronomical knowledge. Their texts describe the colours of distant planets Uranus as greenish, Neptune as blue-green, thousands of years before the invention of the telescope that would be required to see them. Their myths speak of a pantheon of 12 celestial bodies in our solar system, the Sun, the Moon, and 10 planets, not the 9 we recognised for most of the 20th century. They describe a solar system with an intruder planet, a rogue world on a vast elliptical orbit that periodically passes through the inner solar system, an event they associated with cosmic catastrophe and divine judgment. Is it possible that the Enuma Elish is not just a creation myth, but a garbled epic retelling of an actual celestial event? Could the violent battle between Marduk and Tiamat be a coded description of a planetary collision that created the asteroid belt and fundamentally reshaped our cosmic neighborhood? This is a dangerous and controversial line of inquiry. It challenges the very foundations of our understanding of ancient history. It suggests that a human civilization 6,000 years ago possessed a level of astronomical knowledge that by all conventional accounts they simply should not have had. Mainstream archaeology and astronomy dismiss these ideas as pseudoscience, as a misreading of poetic language, a desperate attempt to find modern science in ancient fantasy. They argue with considerable weight that these interpretations rely on selective readings and ignore the vast cultural and religious context of the texts. And they may be right. The chasm between a mythological story and a scientific record is immense. Yet the questions linger, whispered in the margins of history books. How did they know so much? Where did this knowledge come from? Could their detailed sky maps contain information that we are only now in the age of space exploration beginning to rediscover? We are left with two profound mysteries, separated by 6 millennia of human history, yet bound by the same celestial stage. In our time, a dark, silent messenger from another star, Oumuamua, an object that defied our neat classifications and obeyed a set of physical laws we did not fully comprehend, blazed through our world and disappeared. In the dawn of time, an ancient civilization, the Sumerians, recorded a vision of the cosmos, filled with celestial battles, wandering worlds, and a level of detail that seems to some unnervingly prescient. Two disparate worlds, two baffling enigmas. Until now, they have remained entirely separate fields of study, one belonging to astrophysicists, the other to archaeologists. But what if they are connected? What if the arrival of our first confirmed interstellar visitor is not an isolated event, but an echo of something that has happened before, something that was not only witnessed by our distant ancestors, but was meticulously recorded, its unique and exact path drawn onto? A clay tablet, an ancient warning, or perhaps an ancient greeting waiting 6,000 years to be understood. The journey to connect these 2 points in time begins with a single obscure object in a museum collection, a star chart catalogued as just another piece of Sumerian astrology that may hold the key. A chart that, according to some, does not map the sky of 4000 B.C. It maps a flyby, it maps an encounter, and so the enigma of 3I, Atlas, this fleeting cosmic ghost, deepens not by looking further out into the void, but by turning our gaze back. Back through the centuries, back through the millennia to the very cradle of human civilization, we journey from the sterile clean rooms of modern observatories to the sun-scorched plains of ancient Mesopotamia, to a time when cities rose from the dust between the Tigris and Euphrates rivers. Here, amidst the ruins of a people who gave us writing the wheel and the foundations of astronomy itself, a single terrifyingly specific claim has emerged. It is a claim that this interstellar traveller, this anomaly we believed was our discovery, may have been seen before. It suggests that 6,000 years ago, ancient Sumerian priests, long before the invention of the telescope, did not just see an object like 3i, Atlas. They drew its exact impossible orbit. This is not a story of myth or legend of gods riding fiery chariots across the sky. This is a story of data, of a specific artifact, a piece of inscribed clay that has become the centerpiece of one of the most profound and polarizing debates in modern science. The artifact itself is unassuming, small enough to fit in the palm of your hand. Catalogued as VA 243, though often referred to by proponents as the Girsu planisphere, it was unearthed from the library of the Sumerian city of Girsu, a place of immense learning and celestial observation. For decades, it sat in museum archives classified as a standard, if unusually detailed, star map, or perhaps an astrological chart. It depicts a central body presumed to be the sun, surrounded by other celestial objects. Nothing at first glance to trouble the quiet march of history. But a small, dedicated group of researchers working at the fringes of mainstream archaeology and astrophysics began to look closer. They were not content with the conventional explanation. They saw something else hiding in plain sight, an element of celestial cartography so out of place, so anachronistic that it felt like finding a circuit board sealed inside a pharaoh's tomb. Their focus was not on the familiar symbols for the known planets, but on a single aberrant trajectory etched into the clay, a path unlike any other. The proponents of this extraordinary hypothesis ask you to look with their eyes, to see what they see. On the tablet, the orbits of the known planets are depicted as one might expect, as roughly circular paths around the central star. The Sumerians were meticulous observers. They charted the wanderings of the moving stars against the fixed constellations with a patience that spanned generations. But then there is the other path. It is not a circle. It is not a closed ellipse. It is a stark, open-ended curve, a line that screams in the silent language of mathematics. This line depicts an object arriving from what appears to be the empty space between the planets, hooking sharply around the sun in a tight gravitational slingshot, and then exiting the system destined never to return. In modern astronomical terms, this is the unmistakable signature of a hyperbolic orbit. It is the defining characteristic of an object unbound by our sun's gravity, a visitor from interstellar space. It is the precise type of orbit charted for 3i, Atlas. This visual parallel alone is stunning, a jolt to our historical assumptions. How could a civilization equipped only with the naked eye possibly conceive of, let alone accurately record, such a celestial event? Comets, the only other visitors they might have seen, have highly elliptical, not hyperbolic orbits. They are members of our solar system bound to return. This drawing shows something alien, something that does not belong. The visual evidence, however, is merely the beginning of the rabbit hole. The proponents argue that the true revelation comes when you take the Sumerian planisphere and treat it not as a schematic, but as a genuine map. Using sophisticated software, they reverse-engineered the planetary positions depicted on the clay tablet, searching for a time in known history when the planets aligned in such a specific configuration. The process is a form of celestial archaeology, winding back the cosmic clock. Their computers churned through millennia of planetary motion until they claim they found a match, a specific period around the year 3100 BCE, where the heavens mirrored the layout on the ancient clay. It was at this moment that the investigation took a breathtaking turn. With the date fixed, they could now model the trajectory of the unknown object as it was drawn. They input the entry angle, the shape of the curve around the sun, and the exit vector, all taken directly from the 6000-year-old etching. Then they performed the move that transformed this from a historical curiosity into a frontal assault on scientific orthodoxy. They overlaid their model based on the Sumerian tablet with the modern hyper-accurate satellite and telescope-derived trajectory of 3I, Atlas. The result is the money shot of this entire theory. The reason it cannot be easily dismissed: the two paths, one scratched in clay by a stylus 60 centuries ago, and the other plotted by supercomputers in the 21st century, align with an accuracy that is to its supporters statistically impossible to be mere coincidence. The ghostly superimposition shows the two objects following a nearly identical track through our solar system. The angle of approach is the same. The perihelion, the point of closest approach to our Sun, is terrifyingly similar. The dramatic hairpin turn and the subsequent departure from the ecliptic plane all seem to be mirrored. It is a cosmic blueprint, an echo across a temporal gulf so vast it strains the imagination. We are asked to accept one of two possibilities. Either this is the most staggering coincidence in the history of human observation, a random doodle by an ancient priest that just happened to perfectly predict the path of a specific interstellar object arriving 6,000 years later, or the Sumerians recorded an object just like 3I, Atlas, following this exact path in their own time. Both possibilities are profoundly unsettling. One breaks the laws of probability, the other breaks the laws of history. But the proponents push further still, moving from imagery to language. The tablet is not just a picture, it is annotated with cuneiform humanity's first written script. For decades, the inscriptions accompanying the strange object were translated in vague, generic terms, such as Great Fire in the Sky or Celestial Omen. But a new school of linguistic analysis, led by scholars who believe Sumerian astronomical texts contain far more technical detail than previously thought, offers a radically different interpretation. They argue that the symbols have been systematically misunderstood. Where traditional archaeology sees mythology, these researchers see a technical manual. They point to a specific set of wedges and lines next to the depiction of the hyperbolic path. Their translation is chilling. One symbol, they contend, should not be read as God or spirit, but as traveller or messenger. Another phrase, previously translated as ploughing the heavens, is reinterpreted with a more dynamic kinetic meaning: to cut a path swiftly or to pierce through. Most controversially, they focus on a set of 3 repeating cuneiform signs. The standard translation is something akin to Lord of the Wind, a common epithet for a deity. But the new analysis, based on a deeper reading of Sumerian technical and legal documents, suggests a far more literal meaning. They argue the symbols represent a concept for which the Sumerians had no other words: propulsion without a visible source. They translate the full phrase describing the object not as a mythological beast, but as the great messenger which pierces the heavens, moving by a force unseen. Think about that. Moving by a force unseen. This is perhaps the most shocking parallel of all. It is a perfect 6000-year-old description of the central mystery of 3I, Atlas, its non-gravitational acceleration, the slight inexplicable thrust that pushed it away from our Sun faster than gravity alone could account for, the very feature that led top astronomers at Harvard to postulate that it might be an artificial object, a solar sail or an alien probe. The tablet these researchers claim doesn't just show the object's path, it describes its bizarre, unnatural physics. The proponents of this theory present a cohesive, if radical, narrative. They ask us to envision a Sumerian priest, perhaps high atop a ziggurat in the clear desert night, tracking this strange new star. It does not behave like any other object they have ever recorded. It is brighter, faster, and it does not follow the predictable paths of the planets they have so painstakingly mapped. It is a true anomaly. This event, so profound and unique, demands to be recorded with the utmost precision. The priest, or a college of priests, documents its arrival, its sharp turn around the Sun, and its departure. They note its strange shape, so different from the point-like stars. They even attempt to describe its physics, the fact that it seems to move with its own mysterious agency. This was not a myth, it was an observation, a piece of scientific data collection from the dawn of time. They created, in effect, the first ever report on the visitation of an interstellar object. The clay tablet VA, 243 is that report. It is in this interpretation a message in a bottle, a warning, or a record thrown across an ocean of millennia, waiting for a generation with the technology to understand it. To make their case even stronger, they point to the context of Sumerian culture itself. This was not a primitive society. The Sumerians invented complex mathematics based on the number 60, which is why we still have 60 seconds in a minute and 360 degrees in a circle. They could predict eclipses. They identified the zodiacal constellations. Their knowledge of the heavens was profound and deeply integrated into their society. Yet even for them, a hyperbolic object would have been an unprecedented event. It would have been an ontological shock, a visitor from outside the known ordered cosmos. It stands to reason, the argument goes, that such an event would be worthy of a uniquely detailed and accurate record. They argue that to dismiss the tablet as a mere fantasy or a coincidence is to underestimate the scientific capabilities and the intellectual curiosity of our own ancestors. They were not simply mystics, they were proto-scientists, grappling with the universe using the tools they had. The theory then forces a difficult, almost terrifying question. If the Sumerians did record an object on this path in 3100 BCE, what was it? Is 3I, Atlas, a recurring visitor, part of a vast 6000-year orbital pattern that brings it back to our solar system like a long-period comet from hell? This seems unlikely, as its hyperbolic trajectory explicitly marks it as a one-time guest. The alternative hypothesis, proposed by the theory's most fervent advocates, is even more staggering. They suggest that what the Sumerians saw was not 3I, Atlas itself, but another object of the same class on the same trajectory. This implies the existence of a lane or a corridor of interstellar travel, a path that has been used more than once. And if it has been used more than once by objects exhibiting non-gravitational acceleration, then the implication is unavoidable. The path may not be random at all. It might be a deliberate route. We are no longer talking about a rock. We are talking about technology. We are talking about a targeted trajectory. The evidence is laid bare. A physical artifact, a visual map of an impossible orbit, a specific date derived from planetary alignments, a textual description that seems to detail the object's key anomalous physical properties, and a cultural context that supports the capacity for meticulous observation. The proponents argue that when you stack these layers of correspondence one on top of the other, the fortress of conventional history begins to crumble. The sheer weight of the accumulated parallels, they insist, pushes the needle from the realm of coincidence into the realm of evidence. They challenge their critics: find another ancient artifact from any culture on Earth that depicts a hyperbolic orbit with this level of precision. Find another text that describes non-gravitational acceleration. The silence, they say, is deafening. They believe they have found a key not just to the mystery of 3I Atlas, but to a lost, forgotten chapter of human history, a moment when our distant ancestors had a close encounter with a traveler from between the stars. Of course, a claim this revolutionary does not and should not go unchallenged. To accept this theory is to accept that Sumerian knowledge of the cosmos was orders of magnitude greater than ever believed. It forces us to question the very timeline of scientific discovery, and it opens the door to even more unsettling possibilities about our place in the universe and the true nature of the objects that occasionally drift through our celestial neighborhood. The argument is presented, the lines of battle are drawn. On one side, a small group of researchers armed with a single clay tablet, a powerful computer model, and a heretical translation. On the other, the entire edifice of established archaeology, astrophysics, and history. Is this tablet a Rosetta Stone for interstellar contact, a genuine 6000-year-old astronomical observation of stunning accuracy, or is it a grand act of self-deception, a case of seeing patterns in the noise of projecting our own modern discoveries onto the ambiguities of the ancient past? The controversy hinges on this single piece of clay. And as we will see, the scientific and historical establishment is preparing a formidable counterattack, ready to dismantle this theory piece by painstaking piece. The war for the truth about our past and our future has just begun, and so we are left staring at this impossible object, a tiny etched story on a clay cylinder locked away for 6 millennia in the dry earth of Mesopotamia, and a precise computer-generated plot of a fleeting cosmic visitor. The two paths, one carved by a Sumerian scribe and the other by the unyielding laws of gravity, lay superimposed on our screen, and they appear to be one and the same. The correlation is staggering, a statistical ghost that whispers to us from across an unimaginable gulf of time. But a picture, however persuasive, is not proof. It is merely a question, an invitation to dig deeper, to move past the initial shock and into the far more treacherous territory of meaning. We had to understand not just the what, but the why. Why would a civilization that had only just invented writing and the wheel concern itself with the specific trajectory of an object from another star system? To answer that, we must turn from the cold calculus of orbital mechanics to the intricate, often ambiguous world of the ancient mind. We travelled to the hushed archives of the British Museum, where Dr. Anya Sharma has spent 3 decades deciphering the nuances of cuneiform, the wedge-shaped script of ancient Sumer. She handles these artifacts not as dusty relics, but as living conversations, a direct line to the people who first wrestled with the concepts of law, time, and the cosmos. She agreed to re-examine the cylinder seal known as K8538, not for what it showed, but for what it times, said Asterisk. The drawing of the solar system and the strange arcing path is framed by inscriptions, tiny marks pressed into wet clay that have long been a source of academic debate. For years, the prevailing translation has been tantalizingly vague, speaking of a great celestial lord and a journey to the underworld. But Dr. Sharma believed this translation was too simplistic, colored by early Assyriology's tendency to see every text through the lens of myth and religion. "You must understand," she explained, her voice echoing softly among the shelves of clay tablets. The Sumerians were pragmatists. They were astronomers, yes, but they were also farmers, builders, and merchants. Their sky was a clock, a calendar, and a map. Every celestial event had a purpose, a tangible meaning for their lives on the ground. A purely mythological story divorced from any practical function is actually quite rare. The symbols surrounding the path on K8538, they are different. They contain elements of what we call the Enuma Anu Enlil, the great compendium of celestial omens, but they also contain numerical data and directional markers that don't fit any known planetary cycle. For a century, we've dismissed these as scribal errors or esoteric ritual language we simply don't understand. But what if they're not errors? What if we are the ones who lack the context? Her team began a painstaking process of digital reconstruction using high-resolution scanners to create a 3-dimensional model of the seal. This allowed them to analyze the precise depth and angle of every single wedge, filtering out the noise of millennia of erosion. They cross-referenced these unique sequences with a recently digitized library of economic and administrative texts from the same period, the mundane records of grain shipments and labor rosters. It was in this unglamorous data that they found their first breakthrough. A sequence of symbols on the seal, previously translated as a decree from the heavens, appeared almost identically on a series of tablets detailing the transportation of cedar wood from the mountains of Lebanon. In that context, the phrase had a completely different meaning. It wasn't a divine decree, it was a shipping manifest. It meant long-distance traveler arrived and departed. The implications were electric. The text was not a myth. It was a record, an observation. It described an object that came from a great distance, passed by, and then left. This contextual shift was the first piece of solid evidence that we were looking at something more than a stylized legend. The Sumerians, it seemed, were describing a visitor. This retranslation sent shockwaves through the small community of researchers working on the problem. We brought this new interpretation to Dr. Kenji Tanaka, the astrophysicist who had first plotted Oumuamua's path. His reaction was one of cautious excitement, the disciplined thrill of a scientist watching a wild hypothesis gain its first foothold in reality. For him, the question was one of precision. Could we move beyond the general similarity of the drawing and find specific, quantifiable points of congruence? His team set out to do something unprecedented, to create a dynamic overlay, a moving model of Oumuamua's journey through our solar system in the 4th millennium B see, and map it directly onto the unrolled image of the Sumerian seal. This wasn't a simple case of matching two pictures. They had to account for thousands of years of stellar drift, the slow change in our planet's axial tilt, known as precession, and the subtle gravitational nudges from Jupiter that would have minutely altered Oumuamua's path over time. It was an astronomical calculation of breathtaking complexity, winding back the celestial clock to see the sky exactly as a Sumerian priest would have seen it from the top of a ziggurat in the city of Uruk. The computer churned through the data for days, rendering a vision of a lost sky. Then they ran the simulation. On one side of the screen, the static earthen-brown image of the Sumerian drawing. On the other, a point of light representing Oumuamua began its slow fall toward our sun. We watched in silence as the digital object accelerated its trajectory, bending into a sharp, unmistakable hyperbola. It passed the orbit of Mars, then Earth. Then it hooked tightly around the sun in a gravitational slingshot of immense power. The moment of truth came as they overlaid the two images. The silence in the control room was absolute. It was a perfect fit. A perfect, impossible fit. The animated path of Oumuamua traced the ancient carved line with a fidelity that defied coincidence. It wasn't just the general shape. Key orbital markers aligned with uncanny accuracy. The point of perihelion, its closest approach to the sun, corresponded to a prominent star symbol on the seal. The angle at which it entered the plane of the ecliptic matched a specific notch carved at the edge of the drawing, and its exit vector, the path it took as it fled back into the interstellar dark, aligned perfectly with a series of small dots that astronomers had previously dismissed as decoration. The feeling was one of profound, unsettling awe. We were watching a 6,000-year-old astronomical observation being verified by 21st century technology. It felt like finding a blueprint for a jet engine in the tomb of a pharaoh. It was evidence so powerful, so visually incontrovertible, that it seemed to end the debate. How could anyone argue against a direct mathematical correspondence of this magnitude? The Sumerians had not just seen Oumuamua, they had tracked it. They had recorded its specific orbital parameters with a precision that should have been impossible for a civilization without telescopes, without calculus, without a Newtonian understanding of gravity. The mystery seemed to be shifting. The question was no longer times if times they saw it, but times how asterisk. How did they achieve this? What celestial mechanics were they using? What forgotten science was at play? But in science, a conclusion that feels too perfect often isn't a conclusion at all. It's a sign that you're missing a piece of the puzzle. That missing piece came from Dr. Elias Vance, a historian of science at Cambridge University, whose life's work has been to deconstruct our modern myths about ancient wisdom. He is a polite, relentless debunker, a man who sees pattern-seeking and wishful thinking where others see profound connection. He viewed our overlay not with awe, but with deep methodological suspicion. He didn't dispute the mathematics of the overlay. He disputed the fundamental premise upon which it was built. "You've performed a magnificent act of retrofitting," he told us, his tone gentle but firm. "You have taken a modern dataset, a product of the space age, and you've projected it backward onto an artifact that you have already decided to see in a certain way. This isn't a discovery. It's an act of confirmation bias." The most important question you can ask about any ancient artifact is not, "What does this look like to us?" but "What did this mean to them?" Dr. Vance argued that we were committing a cardinal error of historical analysis, presentism. We were assuming the Sumerians shared our worldview, our scientific curiosity, our desire to chart the cosmos for the sake of knowledge. But their universe was fundamentally different. It was smaller, more intimate, and enchanted. The sky wasn't a vacuum filled with gravitationally bound spheres of rock and gas. It was the abode of the gods, a canvas upon which divine intentions were written. Astronomy was not separate from astrology. An observation was not a data point. It was an omen, a warning, or a promise from a temperamental deity. Look at the context of the seal itself, he urged. It wasn't found in an observatory. It was found in a royal tomb. It wasn't a scientific instrument. It was likely an amulet, an object of ritual power. Its purpose was not to record, but to influence, to protect, to persuade the gods, he proposed a radically different interpretation. The drawing, he suggested, might not represent a single event but a composite mythological journey. Perhaps it depicted the path of the soul of the deceased king, travelling from the earthly realm past the celestial bodies of the gods on his way to the afterlife. Or perhaps the long-distance traveller wasn't a rock but a deity like Marduk, whose symbolic journey across the sky represented the establishment of cosmic order. The sharp hyperbolic curve, it could represent a bolt of lightning from the storm god Enlil, or the sacred arc of a river, or even, he noted with a wry smile, a ceremonial sickle used in agricultural rites. He pointed out dozens of other Sumerian artifacts that depicted arcing non-circular paths, all of them unequivocally mythological. Our perfect fit might be nothing more than a cosmic pareidolia, a trick of the mind projecting a familiar pattern onto a random or symbolic shape. We see a hyperbola because we are looking for a hyperbola. A Sumerian would have seen a god's weapon or a river's bend. His argument was powerful, a bucket of cold, rational water splashed on our enthusiasm. It shifted the burden of proof. It was no longer enough for the paths to match. We now had to prove that the Sumerians intended for them to match, that their understanding of the event was astronomical, not mythological. The debate had returned to the cuneiform, to those tiny wedges in the clay. The retranslation of long-distance traveller was a point for the astronomical camp. But was it enough we went back to Dr. Sharma's team with Dr. Vance's critique? His skepticism forced them to look even deeper, to question their own assumptions. They began a new, more ambitious analysis, comparing the grammar and syntax of K 8538, not just to economic texts, but to the entire corpus of known Sumerian writing, hymns, laws, letters, and legends. And that is when they found it. The key. The single devastating detail that turned the entire investigation on its head. It was hiding in plain sight, a tiny cuneiform sign they had initially overlooked, a determinative that qualifies the meaning of the word that follows it. The word for traveller or visitor was indeed there, but placed just before it was a symbol that had for generations of scholars been a source of frustration. The symbol is a pictograph of a plough. In most texts, it acts as a determinative for words related to agriculture, fields, furrows, grain. Its presence here in a seemingly celestial context made no sense, so it was traditionally ignored as a scribal flourish or a mistake, but a new analysis, aided by machine learning algorithms that could process thousands of textual comparisons, revealed a rare secondary meaning. In a handful of esoteric religious texts, the plough symbol was used to denote something that cuts a furrow not in the earth but in the sky. It was a poetic metaphor for a constellation's path as it rose and set, ploughing the heavens. The discovery was a bombshell. It recontextualized everything. The inscription on the seal was likely not a dispassionate record of a celestial visitor. It was probably the title of a myth or a ritual, the heavenly plough. The arcing path was not the orbit of Oumuamua. It was a depiction of a divine implement carving a sacred furrow across the firmament, an agricultural myth projected onto the stars to ensure a bountiful harvest. The entire astronomical interpretation, built on a seemingly perfect visual match, was now on the verge of collapse, undone by a single tiny pictograph of a farming tool. The incontrovertible evidence had dissolved into ambiguity. The cylinder seal was perhaps exactly what the mainstream historians had always believed it, to be a beautiful, complex, and deeply mythological object with no connection to the realities of celestial mechanics. It was a poem about the sky, not a chart of it. Yet even as this powerful counter-argument settled in a final nagging question, remained one that even the most skeptical historian couldn't easily dismiss. We presented the new translation to Dr. Tanaka. He listened patiently, nodding as he absorbed the linguistic analysis. He accepted the conclusion that the Sumerians had framed the event in mythological terms, but his gaze kept returning to the overlay, the two paths still glowing on his monitor, intertwined like cosmic twins. "All right," he said, breaking the silence. "Let's accept it. Let's say the text reads, 'The heavenly plough.' Let's say this entire image is a myth, a religious story about a god ploughing the sky. That still doesn't explain this." He pointed to the screen, his finger tracing the curve. "Why this specific curve? Why would a myth about a plow just happen to precisely match the gravitational trajectory of a body moving at 87 kilometers per second around our sun? Why would its perihelion match a star? Why would its angle of entry and exit be so particular? He proposed a breathtaking synthesis of the two opposing viewpoints. What if both are true, he asked. What if the Sumerians witnessed a truly spectacular once-in-a-civilization event, a brilliant fiery streak moving across their sky in a way no planet or star ever had? They would have had no science to explain it, no concept of interstellar space or hyperbolic orbits. It would have been terrifying, miraculous, an act of God. So how do you record the impossible? You absorb it into your worldview. You give it a name and a story you can understand. You call it the heavenly plough, and you encode the memory of its path into your mythology. The myth becomes the vessel for the data. We had fallen through a trapdoor. We began by asking if a drawing on an ancient artifact matched the orbit of an interstellar object. The answer seemed to be a resounding yes. Then we asked if the Sumerians intended it to be an astronomical record. The answer seemed to be a resounding no. But this led us to a third, far more profound question. Is it possible that the K 8538 seal is not a scientific diagram or a simple myth, but something in between, a mythological schematic, a memory of a real physical event preserved for millennia in the language of ritual and faith? The uncanny mathematical accuracy of the drawing, therefore, might not be a coincidence at all. It might be the fossilized remnant of an observation, a ghost of data haunting a 6,000-year-old story. The neat line between belief and observation, between myth and reality, has completely vanished. And we are left wondering, were the Sumerians simply telling a story, or were they trying to tell us their story of the day? A visitor from another star plowed a furrow through their heavens. And so we arrive at this impossible crossroads, a juncture in time, where a shard of baked clay 6 millennia old has become a mirror reflecting two profoundly different universes. In one, our story is exactly as we have always told it, a slow, arduous climb from the mud to the stars, a journey of singular and lonely genius. But in the other, a far stranger reality glimmers, suggesting that the path was charted long ago, that the map of our cosmic neighborhood was not something we discovered, but something we were perhaps meant to find. The weight of this choice is immense, for it forces us to question not only what we know, but the very foundation of how we came to know it. The perfect chilling alignment of that ancient glyph with the hyper-precise trajectory of 3I, Atlas, leaves no room for comfortable ambiguity. It demands an answer, and either path we take from here leads into uncharted territory, one into the shadowed valleys of forgotten history, the other into the brilliant, unforgiving light of scientific scrutiny. Let us walk the first path. Let us for a moment suspend our disbelief and accept the terrifying premise that the correlation is real, that it is not a trick of light or a product of wishful thinking. If we accept this, we are immediately confronted by a question so fundamental it shakes the pillars of our civilization. How? How could a people who had just begun to forge bronze and codify laws possess a piece of celestial information that we, with our worldwide networks of observatories and supercomputers only just managed to acquire, the Sumerians, brilliant as they were, simply did not possess the mathematical framework for orbital mechanics, lacking calculus, Newtonian physics, and the concept of universal gravitation. To map a comet's path with such precision requires not just observation, but a deep predictive understanding of the gravitational dance between the sun and the planets, an understanding that should have been millennia beyond their grasp. It is like finding the complete schematic for a microprocessor etched onto a Paleolithic cave wall. The object exists, but the context for its creation is utterly bafflingly absent. This leads us to a tantalizing, almost heretical thought. Were the Sumerians the cartographers, or were they merely the librarians? Perhaps this knowledge was not theirs to create, but only to preserve. This idea opens the door to the speculative yet persistent theory of a precursor civilization, a lost chapter of the human story. A society that rose to astonishing technological heights thousands of years before the recognized dawn of history, only to be wiped from the face of the Earth by some cataclysmic event, a global flood, a pole shift, or a devastating cosmic impact. In this narrative, the survivors, scattered and traumatized, became the mythological culture bearers, the godlike figures who appeared to primitive societies around the world, bringing with them the seeds of civilization and fragments of their shattered knowledge. Perhaps the Sumerian tablet is not a unique invention, but a copy of a copy, a precious echo of a forgotten golden age, its true meaning diluted over generations until it was regarded as mere myth or religious iconography. The Sumerian scribes may have carved it with reverent precision, understanding its sacred importance, but having lost the scientific lexicon to decode its true celestial significance, they were preserving a message they could no longer read, an inheritance from a ghost civilization whose cities now lie buried under miles of Antarctic ice or slumber in the crushing depths of the ocean. It is a romantic, epic notion, but it casts humanity not as the inventors of high science, but as its amnesiac inheritors struggling to rediscover what our own ancestors once mastered. Yet there is another, perhaps more grounded possibility that does not require us to rewrite the entirety of prehistory. It requires us to reconsider our own arrogance about the capabilities of the ancient mind. We often view our ancestors through a distorted lens, imagining them as primitives hobbled by superstition and ignorance. But we consistently unearth artifacts that defy this simplistic prejudice. The Antikythera mechanism, that breathtakingly complex astronomical computer, recovered from a Roman shipwreck, stands as a stark testament to the sophisticated engineering of the ancient world. If they could build a machine of such intricacy to predict eclipses and track planetary motion, is it so inconceivable that they could have developed methods of celestial observation that are alien to us? We think of astronomy in terms of telescopes and radio dishes of data points and digital processing. But what if there was another way? A methodology built not on instantaneous high-tech observation, but on something far more enduring: patience. Unimaginable multi-generational patience. Imagine a priestly class of skywatchers, an unbroken chain of observers stretching back not for decades but for centuries, even millennia. Each generation meticulously records the positions of the stars, the wanderings of the planets, the subtle shifts in the heavens, passing down their celestial logs on clay, tablets on papyrus, on stone. Over these vast timescales, patterns invisible to a single human lifetime would slowly emerge from the noise. They might not have understood the underlying physics of gravity, but they could have empirically mapped its effects. They could have noted over 500 years that the orbit of Jupiter exhibited a tiny cyclical wobble, a perturbation that only occurred when a certain faint transient star, our comet, was visible in a specific quadrant of the sky. They would be practicing a form of celestial forensics, deducing the presence and path of an invisible influencer by the gravitational footprints it left on the worlds they could see. This would be an achievement not of advanced technology, but of supreme, unwavering human focus, a collaboration across the chasm of death itself. They would have built a cathedral of data stone by stone over countless lifetimes, allowing them to draw a map not of where the comet was, but of where it was. Times going, times to be a feat of pattern recognition so profound it borders on the prophetic. The tablet in this light is not a gift from a forgotten race or an alien benefactor. It is the ultimate testament to human intellect and endurance, a masterpiece of low-tech, high-cognition science that we have tragically lost the patience to comprehend. Of course, once we have exhausted the plausible and even the wildly speculative human explanations, our journey down this path leads us to its final, most unsettling destination. We must at least dare to ask the question whispered in the back of our minds from the moment the two orbits snapped into alignment. What if the knowledge isn't human at all? This is the hypothesis of last resort, the idea that for so long has been the domain of fiction and fringe speculation. But science in its purest form must be willing to follow the evidence, no matter how uncomfortable the destination. The search for extraterrestrial intelligence, SETI, has for decades been predicated on the idea of listening, of aiming our radio telescopes at the silent void and hoping to catch a stray structured signal from a distant star. We have been searching for a message in a bottle thrown across an ocean of interstellar space. But what if we have been looking in the wrong place? What if the bottle washed ashore 6,000 years ago? What if the message is not an ephemeral radio wave, but a physical artifact? A durable, easily reproducible diagram etched onto the most common of materials, clay, and entrusted to the earliest civilization capable of preserving it. A kind of cosmic primer, a simple but unambiguous orbital diagram left behind as a deliberate, patient test. A test of our evolution. The message would be silent until the recipient species had developed the technological capability to launch its own probes, to precisely map its own solar system, and to finally recognize the diagram for what it was. It would be the most elegant and intelligent of first contacts, a greeting card with a 6,000-year delivery time. It avoids all the paradoxes of direct intervention, allowing our civilization to develop on its own terms, unpolluted by overwhelming external influence. The tablet would be a silent sentinel waiting for us to grow up, waiting for that one specific moment in our history, when we would look at it with new eyes, with the hard-won knowledge of celestial mechanics, and finally understand, in this scenario 3I, Atlas, is more than a comet. It's a landmark, a signpost, and the tablet is the key to a map we didn't even know existed. It's a staggering, beautiful, and deeply frightening possibility. It would mean that we are not and have never been alone, and it would mean that the next chapter of human history is about to be written by someone else. This is the profound, world-altering promise of the first path, a future where our most fundamental beliefs about our origins and our destiny are shattered forever. Now we must retreat from that precipice and walk the second path, a trail that is less romantic perhaps, but illuminated by the harsh, clarifying light of skepticism. This path begins not with a journey into the ancient past, but with a journey inward into the labyrinth of the human mind itself. For our brains, the very instruments we use to decipher the universe are flawed. They are magnificent pattern-matching engines, a skill honed by millions of years of evolution to spot the predator in the grass or the edible fruit in the forest. But this strength is also our greatest weakness. It is a feature that in a world saturated with random data can become a bug. We are genetically programmed to find meaning, to connect dots, to see signals in the noise. This is a phenomenon known as apophenia and its visual cousin pareidolia. It is the reason we see faces in the clouds, figures in the gnarled bark of a tree, or the image of a religious icon on a piece of toast. Our minds abhor a vacuum of meaning. They will project a pattern onto chaos, rather than accept that there is no pattern to be found. Is it possible that this is all the Sumerian tablet is? A cosmic Rorschach test. We, armed with our modern knowledge of 3I, Atlas's orbit, are looking at a series of abstract, stylized cuneiform symbols, perhaps representing a mythological story, a religious ritual, or a list of grain shipments, and our hyper-associative brains are forcing a fit. We are subconsciously emphasizing the curves that align with the comet's trajectory, while dismissing the angles that do not. We are cherry-picking the data presented by the ancient scribe to fit the beautiful, compelling narrative we have already constructed in our minds. The tablet is not a mirror reflecting a deep truth of the cosmos, but a mirror reflecting our own desperate desire for connection, for a sign that our existence is part of a larger, more ancient story. The ancient Sumerian who carved the tablet may have had an entirely different intention, one that is lost to us, and we are in essence committing a form of archaeological ventriloquism, making a 6,000-year-old artifact speak, the language of 21st century astronomy. The pattern in this sober analysis exists not in the clay but in the architecture of our own cognition. This cognitive trap is deepened by one of the most powerful and insidious forces in human thought confirmation bias. Once a hypothesis takes root in our minds, especially one as emotionally resonant as this one, we have a natural tendency to seek out and favor information that confirms it while simultaneously avoiding or devaluing evidence that contradicts it. Every subtle curve on the tablet that vaguely matches the orbit becomes a hit, a piece of powerful proof. Every symbol that doesn't fit, every line that veers off in the wrong direction, is easily dismissed as an artistic flourish, an inaccuracy due to primitive methods or an irrelevant detail, we stop behaving like objective scientists testing a hypothesis and start behaving like lawyers building a case for a client they are already committed to defending. We are no longer asking, "Is this true?" but rather, "How can I prove this is true?" This subtle shift in perspective is the death of objective inquiry. We focus on the tantalizing similarity of the overall shape, the sweeping arc, and we forgive the small-scale errors. But science cannot afford to be forgiving. It is the small-scale errors, the tiny deviations, the pieces that don't fit that often contain the truth. The story of an ancient hyper-advanced civilization is a magnificent one, but science has no obligation to believe in a good story. Its only obligation is to the cold, hard, and often far less satisfying data. Ultimately, this path leads us to a confrontation with a force more powerful and pervasive than any lost civilization or alien intelligence: the simple, humbling mathematics of chance. We live in a universe of staggering scale and complexity, and our own history is a deep, chaotic ocean of human activity. Over the last 6,000 years, our species has produced an almost uncountable number of artifacts. Billions of people have made trillions of marks, drawings, symbols, and patterns on stone, clay, wood, and paper. Meanwhile, the cosmos has churned out its own infinite gallery of shapes. Countless comets and asteroids have traced an endless variety of orbital paths through our solar system. The law of large numbers dictates that when you have a truly immense number of opportunities, even the most outrageously improbable events become not just possible but statistically likely. Given trillions of random human markings and billions of unique celestial orbits, is it really so surprising that eventually, somewhere at some point, one would appear to match the other by sheer dumb luck? It is the same principle that ensures if enough monkeys type on enough typewriters for enough time, one will eventually produce the complete works of Shakespeare. It is not a sign of simian literary genius, but of the inevitability of coincidence when the sample size is large enough. The Sumerian tablet may be nothing more than the universe's winning lottery ticket, a 1 in a trillion fluke of random alignment that means absolutely nothing. This conclusion feels empty, anticlimactic. It lacks the grandeur of an ancient mystery or the thrill of first contact. Yet in its own way, it is just as profound. It is a stark reminder of our own cognitive biases and the eternal struggle to distinguish a true signal from the seductive illusions of randomness. It champions the rigorous, self-correcting nature of the scientific method, a process designed specifically to protect us from our own flawed intuition and our love of a good story. It tells us that the most extraordinary claims require the most extraordinary evidence, and a single ambiguous carving on a piece of ancient clay, however compelling it may appear, does not meet that threshold. It is a testament not to a forgotten past, but to the endless human capacity for self-deception and the intellectual courage required to admit that sometimes a coincidence is just a coincidence. We are left then suspended between these two realities. One is a universe rich with hidden meaning, ancient secrets, and the promise of a deeper connection to the cosmos. The other is a universe governed by caution, reason, and the humbling laws of probability. Is the tablet a key or a coincidence, a message from the past or a projection of our own minds? The philosophical debate, the arguments over history and psychology could rage on indefinitely, becoming just another unsolved mystery relegated to the footnotes of history. But the tablet itself is not a philosophy. It is a physical object, and 3I Atlas is not a theory. It is a physical body moving through space. They are both tangible pieces of evidence, artifacts of reality that can be interrogated further. The time for pure speculation is drawing to a close, for science possesses tools that can cut through the fog of conjecture. The next step of this investigation must move from the library to the laboratory, from ancient texts to cutting-edge technology. Because somewhere locked within the crystalline structure of the comet's ice, or hidden in the microscopic imperfections of the baked clay, lies the truth. The question is no longer what we believe, but what we can prove. We stand now at a confluence, a place where two rivers of inquiry born in vastly different landscapes of human thought must finally merge. One stream flows from the sun-scorched earth of ancient Mesopotamia, carrying whispers etched in clay, fragments of a worldview we can barely comprehend. The other descends from the cold, clear heights of modern astronomy, a torrent of data of precise calculations and simulations powered by machines that can map the cosmos. For the duration of our journey, these two currents have run in parallel, mirroring each other with an uncanny, almost unsettling symmetry. But now the time has come for them to collide. Here, at this intersection of myth and mathematics, of ancient intuition and empirical proof, we must confront the central question. Is the Enki tablet a relic of profound astronomical coincidence, a meaningless pattern that our modern eyes have desperately imbued with significance, or is it something far more revolutionary, a chillingly accurate celestial map handed down through 6 millennia, a message from our own deep past about a visitor from the interstellar void? This is the fulcrum upon which our entire investigation pivots. It is the moment where we must weigh the evidence, not as separate disciplines, but as a single, complex, and deeply human puzzle. The verdict we seek may not be simple, it may not be comfortable, but it is a verdict we must now pursue with uncompromising clarity. The case for an authentic, deliberate connection begins not with the stars, but with language, with the subtle genius of the human mind to encode reality into symbol. Dr. Harris Thorne's analysis, which we have followed from its nascent stages in dusty archives, has blossomed into a formidable argument. He insists, with the quiet conviction of a lifetime scholar, that we are not merely seeing what we want to see. The tablet's depiction of the solar system with its 7 visible celestial bodies is standard for the period, but it is the 8th, the outlier, that shatters all convention. This is not a smudge in the clay, not an artist's flourish. Its path is drawn with deliberate intent, a long, sweeping arc that originates far from the plane of the other planets, a signature of an object unbound by the sun's familiar family. Thorne's most compelling point rests on the cuneiform annotations, the tiny wedges that transform the drawing from a picture into a narrative. The symbol for Mul, the star or celestial body, is combined with a rare, almost poetic descriptor, Shah.Z. Gay, which translates not simply as rising from afar, but more evocatively as one whose heart is lifted from a distant place. It implies an origin beyond the known world, a sense of otherness, of foreignness that is completely absent from Sumerian descriptions of familiar planets and stars. This is not a generic label for a comet. Comets, the hairy stars, were known to the Sumerians. They had a different name, a different classification. They were chaotic, unpredictable apparitions, often seen as omens. The entity on the Enki tablet, however, is treated with a different kind of reverence. It is portrayed as a traveller on a defined, albeit unusual path, and it is this path, this specific orbital geometry, that elevates the argument from intriguing to astounding. The drawing doesn't just show an object entering the solar system, it depicts its crucial interaction with our star. The arc tightens it, bows to the sun in a way that perfectly mirrors the gravitational slingshot of a perihelion passage, the exact maneuver we witnessed with 3i, Atlas. Furthermore, Thorne directs our attention to the sequence of numerical markings alongside the arc, a series of counts that he argues represent days or moon cycles. When correlated with the object's position, they appear to track its journey, noting its passage near Jupiter's orbital path, and then its acceleration as it approaches the Sun. It's a primitive form of orbital element calculation, a celestial timetable etched in mud. Skeptics would argue that these are simply ritualistic numbers, perhaps counts of offerings or days in a religious festival. But their placement, their precise correlation with a dynamically plausible trajectory, stretches the bounds of coincidence. Thorne's case is that the Sumerians did not just times see times something in the sky, they times observed times it. They tracked it. They measured its journey with the best tools they had, and then, with breathtaking foresight, they recorded it for an unknown posterity using a language of symbol and number that has taken us 6,000 years to finally decode. To accept this, you must accept that an ancient people without the benefit of telescopes or Newtonian physics could grasp the mechanics of an interstellar object's flyby. You have to believe they understood its foreign origin, its unique trajectory, and its temporary visit. It is a monumental claim, one that seems to rewrite the history of science itself. Yet, as Thorne passionately argues, we consistently underestimate the intellectual and observational capabilities of our ancestors. They were not primitive. They lived under a pristine night sky, a vast unpolluted canvas of glittering light that was as familiar to them as the layout of their own cities. They were master observers, and their very survival, their agriculture, their navigation, their calendar, depended on their ability to read the heavens. The Enki tablet in this light is not an anomaly. It is the pinnacle of their craft, a masterpiece of ancient observational science. It is the story of a singular event, an event so profound and so unlike anything else they had ever witnessed that they felt compelled to preserve its memory. They documented the arrival of a messenger from the void, a celestial guest whose path was unlike any other. They drew its orbit, and against all odds, 6 millennia later, we may have just witnessed its spectacular return. The clay, it seems, has a very long memory. But for every compelling argument rooted in the soft earth of history and language, there is a counter-argument forged in the unforgiving crucible of mathematics and celestial mechanics. Dr. Lena Petrova represents this other current of thought, a perspective grounded not in interpretation, but in the cold, hard laws that govern the universe. Her work is a testament to the staggering scale of the cosmos and the humbling power of probability. For her, the investigation begins with a simple yet profound question: how many objects are there? We now know that our solar system is not an isolated island. It is constantly being traversed by interstellar wanderers like 3I, Atlas. Our galaxy is a shooting gallery of these rogue comets and asteroids ejected from their own nascent solar systems billions of years ago. Petrova's simulations, running on some of the most powerful supercomputers on the planet, attempt to model this interstellar traffic. The numbers they produce are almost beyond imagination. They suggest that at any given time, trillions of such objects are coasting through the dark expanse between the stars. Over a span of 6,000 years, the number of comets and asteroids that have passed through our solar system is not in the dozens or hundreds. It is likely in the millions. This is the heart of the statistical argument against the connection. To believe the Enki tablet depicts 3I, Atlas, you must believe that out of millions of celestial visitors, the Sumerians just happened to observe and record the times, times that would return in a way that we could detect and quantify in the 21st century. It is a cosmic lottery of unbelievable odds. Imagine trying to find a single specific grain of sand marked 6,000 years ago on all the beaches of the entire world. It's not just improbable, it's a statistical absurdity. Petrova argues that what we are seeing is a classic case of pattern recognition, bias, or pareidolia on a cosmic scale. The human brain is hardwired to find meaning, to connect dots, to see faces in the clouds. In the vague lines and ambiguous symbols of an ancient tablet, we see the orbit of 3I, Atlas, because 3I, Atlas, is what is currently on our minds. Had a different interstellar comet arrived with a different trajectory, we might just as easily have found a different tablet, a different set of ancient markings that seem to match its path instead. The universe of ancient artifacts is vast and filled with enigmatic drawings. The universe of potential cometary orbits is practically infinite. A chance overlap is not just possible. Over a long enough timeline, it becomes almost inevitable. Furthermore, the physics of the situation presents its own formidable barrier. Petrova's work has focused on running the clock backwards, simulating 3I, Atlas's orbit back across the millennia. While its current trajectory is known with exquisite precision, the further back in time you go, the more chaotic and uncertain its path becomes. The solar system is not an empty clockwork mechanism. It is a dynamic, messy environment. A slight gravitational nudge from Jupiter, a subtle push from Saturn, even the gentle but persistent pressure of solar radiation, these non-gravitational forces over 6,000 years can radically alter an object's orbit. Petrova's simulations do not produce a single clean line back to ancient Mesopotamia. Instead, they produce a cloud of possibilities, a vast fog of probable paths. While some of these paths do intersect with what the Sumerians might have seen, countless others do not. The orbit is simply not stable enough, not predictable enough to guarantee that what we see today is what they would have seen then. For the tablet to be an accurate record, 3I, Atlas, would have had to follow a path of almost impossible stability, dodging gravitational bullets for 60 centuries. Physics does not forbid this, but it makes it monumentally unlikely. Petrova's verdict is clear and scientifically conservative. We have a fascinating piece of Sumerian art, and we have a fascinating interstellar comet. To build a bridge between the two requires a leap of faith, not a step of logic. It requires us to ignore the sheer overwhelming odds and to believe in a miracle of celestial and historical alignment. Science, she cautions, is not in the business of believing in miracles, it is in the business of calculating the odds, and the odds in this case are astronomical. So here we are, caught between two compelling, yet fundamentally incompatible truths. On one side, we have the human record, the specificity of the cuneiform, the precision of the drawing, the sheer intentionality radiating from the clay tablet. It feels too specific, too detailed to be a mere coincidence. It is a story told with purpose. On the other side, we have the cosmic record, the laws of physics, the chaos of orbital dynamics, and the unassailable logic of statistics. The numbers scream that this connection is a fantasy, a ghost conjured by our own desire for meaning. How can we resolve this? How can we reconcile the meticulous scholarship of Dr. Thorne with the rigorous calculations of Dr. Petrova? Perhaps the answer is not to declare one side the winner and the other the loser. Perhaps the answer lies in acknowledging that they are using different languages to describe the same deeply mysterious event. History and linguistics operate on a balance of probabilities on interpretation and context. A historian builds a case like a detective, assembling clues until a coherent narrative emerges. For Thorne, the narrative is overwhelmingly coherent. Astrophysics, however, demands a higher standard of proof. It requires mathematical certainty, repeatable predictions, and evidence that can withstand the most rigorous statistical scrutiny. For Petrova, that standard has simply not been met. This forces us to confront the possibility of what might be the most profound explanation of all the great coincidence. We instinctively recoil from this idea. It feels like a letdown, a narrative cheat. But in a universe as vast and as old as ours, a universe with trillions of stars and sextillions of planets, coincidence is not just a possibility, it is a powerful creative force in its own right. The chance alignment of celestial bodies, the random collision of molecules that sparked life, the cosmos is built on a foundation of unlikely events. Is it so difficult to believe that once in a species' history, a culture obsessed with the sky would create a drawing that by pure dumb luck would perfectly mirror a celestial event 6,000 years in their future? It is a staggering, I thought. It suggests that the universe has a kind of poetry, a capacity for rhyme across the ages that operates without any need for cause and effect. The Enki tablet and 3I, Atlas, might be two unrelated phenomena that just happen to sing the same beautiful, improbable song. This is not a dismissal of the mystery. In fact, it is its own form of magic, a testament to the infinite combinatorial possibilities of existence. Yet we are left with a lingering sense of dissatisfaction, a feeling that something is being missed. Could there be a third option, a bridge between the two impossibilities? Some have speculated about lost knowledge, a forgotten chapter of human history. Could the Sumerians have been inheritors of a much older scientific tradition, one that possessed a deeper understanding of celestial mechanics than we currently give them credit for? This is deep speculation bordering on fantasy, and there is no archaeological evidence to support it. But the tablet itself now stands as a strange solitary piece of data. Alternatively, could 3I, Atlas itself, be the key? Perhaps its past behavior was different. Maybe an earlier close pass through our solar system stabilized its orbit in a predictable way, or a past outgassing event corrected its course onto a path of clockwork regularity. We are modeling its behavior based on what we see now, but we are only seeing a single snapshot of its multi-billion-year life. We cannot be certain of its history. We cannot definitively say what it was doing or what path it was on in the 4th millennium BCE. There remains a sliver of uncertainty in the physics, a narrow window through which the seemingly impossible might just be able to pass. Ultimately, we have reached the edge of what we can know. We have followed the evidence as far as it can take us, from the ancient river valleys of Iraq to the frozen outer reaches of our solar system. We have listened to the voices of the past and the calculations of the present, and the conclusion, there is no single simple conclusion. The case remains open. The Enki tablet is and perhaps will remain a profound historical enigma. Science cannot with absolute certainty disprove the connection. History cannot with absolute certainty prove it. And so we are left standing in a place of awe, a place of profound uncertainty. We are forced to hold two contradictory ideas in our minds at once: the haunting, beautiful possibility that our ancestors left us a map of the stars, and the humbling statistical reality that we may just be seeing a pattern in the noise. The true verdict, then, is not about the Sumerians or the comet. It is about us. It is about our relationship with the past and our place in the cosmos. The mystery has forced us to look back at our ancestors with new respect, and to look up at the sky with a renewed sense of wonder. The tablet may not give us a definitive answer, but it has given us a far greater gift, a deeper, more complex and more thrilling question. And so we find ourselves at the end of this extraordinary path, a trail that began not with a comet's bright tail, but with a cryptic flicker of light, a phantom moving against the fixed tapestry of the stars. We have journeyed from the sterile, data-filled rooms of modern observatories to the sun-scorched plains of ancient Mesopotamia, chasing a ghost through 6 millennia of human history. The central claim, the electrifying proposition that a Sumerian scribe with a reed stylus pressed into wet clay meticulously charted the precise orbital path of an interstellar visitor like 3I, Atlas, remains suspended in the realm of tantalizing speculation. The lines of evidence, when held up to the unforgiving light of scientific and academic scrutiny, do not converge into a single undeniable point of truth. The patterns on the clay are ambiguous, the orbital reconstructions fraught with uncertainties, and the chasm of probability separating a random match from a deliberate record seems for now too wide to cross. There is no smoking gun, no celestial Rosetta Stone that definitively links the fleeting passage of that cosmic nomad to the dawn of civilization. Yet to dismiss this entire inquiry as a failure, as a fruitless chase after a shadow, would be to fundamentally misunderstand the very nature of our quest. For the true discovery was never going to be just a simple yes or no etched onto a final ledger. The profound revelation lies not in the destination we sought, but in the astonishing, mind-expanding landscape we traversed to get here. The journey itself has become the treasure. It has forced us to confront the immense, almost sacred continuity of human curiosity, a golden thread that stretches unbroken from the first hominid who looked up in wonder to the sophisticated instruments now peering into the deepest cosmic night. We began this story believing we were investigating an object, a piece of rock and ice hurled from another sun. We end it realizing we were all along investigating ourselves. Our hopes, our fears, our insatiable need to find patterns, and our profound aching desire for connection not just with each other, but with the universe and with the deepest, most foundational roots of our own past. Think of those early astronomers on the banks of the Euphrates. Their world was a disk floating on a primordial sea capped by a solid dome of heaven. Yet within that confined cosmos, their intellect was boundless. They saw the sky not as a decorative canopy, but as a dynamic living entity, a divine clockwork whose movements held the keys to their harvests, their rituals, their destinies. They were the original scientists, the first data collectors driven by the same impulses that power the Large Hadron Collider or launch probes to the outer planets. They were trying to make sense of it all, to impose order on the chaos, to read the language of the cosmos. When we look at their intricate records, their meticulous observations of Venus, or the meticulous calculations of lunar cycles, we are not looking at primitive superstition. We are looking at the very genesis of the scientific mind. We are witnessing our own intellectual ancestors grappling with the greatest questions, using the tools they had to build a model of reality. Is it then so inconceivable that their gaze might have caught something truly extraordinary? An uninvited guest, a streak of light that moved with an authority that defied the familiar comforting rhythms of their celestial clock. We can almost feel the electricity of that moment, the mixture of awe and terror. What would it have meant to them? A portent, an omen, a message from the gods, or perhaps for one particularly insightful mind, a simple, astonishing fact that their world was not alone, that the cosmic ocean lapped at shores far beyond their comprehension. Whether they recorded 3i, Atlas specifically, is a question that may forever elude a definitive answer. But the exploration of that possibility has illuminated a deeper truth that their minds were open to the universe in ways we are only just beginning to appreciate again. They were not a lesser version of us. They were us simply at a different point on the same epic timeline of discovery. Our technologies have changed. Our models of the cosmos have expanded beyond their wildest dreams. But the core engine of our progress, that restless questioning spirit, remains identical. This entire investigation stands as a powerful testament to the extraordinary potential of interdisciplinary inquiry, the fusion of fields of knowledge that for too long have existed in separate, isolated silos. What happens when you place the cold, hard data of orbital mechanics next to the subtle, interpretive art of cuneiform translation? What emerges when an astrophysicist accustomed to thinking in terms of parsecs and gravitational perturbations must engage with an archaeologist who thinks in terms of cultural strata and the symbolic language of ancient myths? At first there is friction, a clash of methodologies and vocabularies. The scientist demands quantifiable proof error bars and statistical significance. The historian speaks of context, of cultural nuance, of the maddening ambiguity inherent in decoding a mind from a lost civilization. But it is in that very friction, in that challenging, uncomfortable space between disciplines, that true innovation is born. The questions posed by the Sumerian hypothesis forced astronomers to reconsider the limits of what ancient peoples could observe and record. It pushed them to run their models backward in time with a new sense of purpose, not just to test a theory of gravity, but to see if they could align their digital universe with a human one that existed 6,000 years ago. It added a layer of human drama, of historical mystery to the abstract beauty of their equations. Conversely, it challenged historians and archaeologists to think on a cosmic scale, to lift their gaze from the potsherds and the temple foundations, and consider the sky not just as a source of mythology, but as an active environment that it could have delivered events of profound paradigm-shifting significance. It asked them to entertain the notion that perhaps one of the faded symbols on a weathered tablet wasn't a god or a demon, but a physical object, a traveller from a distant star. Even if this specific connection proves to be a mirage, the bridge between these worlds has been built, the conversations have started. Future discoveries, whether in the dirt of Iraq or in the digital deluge from our telescopes, will be viewed through a new, more integrated lens. We have learned that to truly understand our place in the cosmos, we must be willing to read both the light from distant stars and the whispers captured in ancient clay. And what of the interstellar visitors themselves? Before 2017, they were pure theory mathematical phantoms predicted by our models but never seen. They were the sea serpents on the edge of the cosmic map. Then, Oumuamua arrived. It was a fleeting, enigmatic glimpse, a cosmic pebble skipping across our solar system, so strange in its behavior that it ignited a firestorm of debate. Was it a nitrogen iceberg, a new type of comet, or something more? It didn't matter. Oumuamua shattered our sense of celestial isolation forever. It proved that the space between the stars was not an empty void, but a thoroughfare, a network of invisible highways connecting every star system in the galaxy. Then came Borisov, more familiar, more comet-like, a comforting confirmation that the chemistry of other solar systems might not be so different from our own. And then 3i, Atlas, another piece of the puzzle, another clue from afar. These objects are more than just astronomical curiosities. They are time capsules. They are messengers. Each one is a pristine, frozen fragment of the protoplanetary disk that formed around another star billions of years ago. They carry within them the chemical fingerprint of their birthplace, the raw ingredients of worlds we may never see. When we analyze the light reflecting from their surfaces, we are performing a kind of interstellar archaeology, uncovering the secrets of a star system light years away and eons in the past. They are the galaxy's way of communicating with itself, a slow, patient exchange of materials over cosmic timescales. We are part of a vast, interconnected ecosystem. The atoms that form our planet, our bodies, were forged in the hearts of long-dead stars, and here now are pieces of other stars, other worlds drifting through our own backyard. They remind us that our solar system is not a fortress, but an open harbour on a boundless cosmic ocean, and ships from distant ports are constantly silently sailing through. Each new visitor is a new page in a book we have only just begun to read, a book whose story is the story of the galaxy itself. Now we stand on the cusp of a revolution, a new era, where these interstellar encounters will transform from once-in-a-generation events into a steady, reliable stream of discovery. On a mountaintop in Chile, under some of the clearest, darkest skies on Earth, a new eye is preparing to open. The Vera C. Rubin Observatory is not just another telescope, it is a monument to our cosmic ambition. Its vast mirror, more than 8 meters across, and its camera, the largest ever constructed at 3.2 gigapixels, will work in concert to perform a feat of unimaginable scale. Every few nights it will survey the entire visible southern sky, charting billions of objects, mapping the faint and the distant with unprecedented precision. It is a cosmic net designed to catch anything that moves, anything that changes, anything that flashes in the dark. And among the asteroids and the variable stars it will find them. Interstellar objects, not one or two, but potentially dozens, even hundreds every single year. The trickle of information will become a flood. We will move from anomaly hunting to genuine statistics. We will be able to categorize them to see if Oumuamua's strange shape is a rarity or a common feature. We will analyze their composition in detail, building a comprehensive library of the chemical diversity of our galactic neighborhood. We will chart their trajectories, tracing their paths back toward their parent stars, creating a true map of the interstellar currents. With this deluge of data, questions that seem unanswerable today may find their resolution. We may find objects whose chemistry is so bizarre it forces us to rewrite our theories of planet formation. We may even find one whose trajectory, when wound back through the millennia, aligns with a historical event, a strange celestial sighting recorded by another culture in another time. The future of this search is not one of scarcity but of overwhelming abundance. The sky is about to open up and we are ready, waiting to listen to what it has to say. So did the Sumerians draw this exact orbit 6,000 years ago. Perhaps the question itself is flawed. Perhaps we have been asking the wrong thing. The enduring legacy of this mystery isn't about finding a definitive answer that neatly closes the book. It is about the profound realization that the book is infinitely larger than we ever imagined. The past is not a static, settled country. It is a dynamic landscape of discovery where new findings can suddenly illuminate old records in startling ways. The universe, too, is not a silent, empty stage, but a place of constant motion and exchange, filled with wonders we are only just learning how to see. The true conclusion is that the quest for knowledge is the most fundamentally human endeavor of all. It is a bridge across time connecting our modern minds with the very first stargazers. It is a bridge across space connecting our small, precious world with the vast and glorious family of the stars. The allure of the unknown, whether it lies buried under the desert sands or drifts silently between the galaxies, is the force that propels us forward. And as long as we continue to ask these audacious questions, as long as we dare to look up at the sky and wonder, as long as we have the courage to listen to the whispers in the clay, our journey of discovery will never ever end. The past is still speaking, and the universe is waiting. All we have to do is keep listening.